Happy day. I am Nalla Perumal. You can call me as NP Mal. Today let us enjoy some chemistry. In chemistry, certain problems can be done in different ways. Let us take this problem in chemistry. Now I will show you how it is done in some standard textbooks using mole fraction method. There is a situation and there are two questions. What is the situation? 50 kilogram of nitrogen gas. You must slightly feel. My weight is 60 kilograms. So you have some idea of what is 50 kilograms. And then we have got 10 kilogram of hydrogen gas. Both are combined to produce ammonia gas. They are going to be combined chemically. One may be in excess. We do not know which is in excess. Whether nitrogen gas in excess or hydrogen gas in excess, we do not know. We are going to find. And ammonia gas will be formed. How many kilograms of ammonia gas will be formed? That is the first question. The second question is limiting reagent. Which one limits the amount of production of ammonia gas? In other words, which will be exhausted first? Whether nitrogen gas will be exhausted first or hydrogen gas will be exhausted first. If nitrogen gas is exhausted first, then nitrogen is the limiting gas. If hydrogen gas is exhausted first, then hydrogen gas is the limiting gas. So we have to find that in the second one. Now this problem can be done in two different ways. One is mole fraction method. Another method is 4-box method. The problems will be easy if you know the basics well. To do this problem, you must know three things well. First, you must know the atomic mass of nitrogen and you must know the atomic mass of hydrogen. Secondly, you must have a good concept of mole. Third one, a 4-box method that I will explain later. Atomic mass of nitrogen is 14 2. In those days, they called it as atomic mass unit. Atomic mass of nitrogen is 14 atomic mass unit. Now we say only 14 2. Atomic mass of hydrogen is 1.008 or 1.008 atomic mass unit. But this, if you want a more accurate answer, you have to use this number. For rough calculations, we can take it approximately equal to 1 U. For rough calculation, we can take this. If you want more accurate answer, you have to use this number. 1 mole is 6.022 times 10 to the power of 23. It's a very huge number. Do you want to feel it? Yes, let us take one method to feel that. If you are not felt, you are not learned. You know GDP, gross domestic product. It is the value of all the goods and services produced in a country. What is the GDP of the USA? The present rate is 17 trillion 10 to the power of 3 thousand, 10 to the power of 6 billion, 10 to the power of 9 billion, 10 to the power of 12 trillion. So 17 trillion, I write 10 raised to the power of 12. So many dollars. That is the total production of goods and services. In how much time? This is the production in 1 week. So it is per week. Per week. We want per annum. So there are 52 weeks in a year, and so we must multiply this by 52. If I multiply this by 52, we will get for 1 year. 17 twos are 34, 3, 17 fives are 85 plus 3, 88, 88, and then this trillion times 10 raised to the power of 12. This is the GDP of the USA per annum. If you have one more dollars, that will be GDP of how many years of the USA? That is the question. If you have one more dollars with us, that will be equivalent to GDP of how many years? For that again we can use 4 box method. 17 times 10 to the power 884 times 10 to the power of 12 will be 1 year GDP. Then one more dollar, 6.022 times 10 to the power of 23 will be the GDP of how many years? If this is the GDP of 1 year, this will be the GDP of how many years? Some number to some other number. Same 4 box method. So this will go to the numerator. This will go to the denominator. And this will go to numerator again under multiplication. Now this we can handle very easily. Here 10 to the power of 12, 10 raised to the power of 23. So if we cancel, it will become 10 raised to the power of 11 in the numerator. But this gives us a problem. 6.022 by 884 times 23 minus 12, 11. 10 raised to the power of 11. To make this problem easier, let us multiply this by 1000 and divide this by 1000. That is, we are going to shift 3 digits to the right and we will reduce 3 here. Then it will become 6.022 by 884 times 10 to the power of 8. To find the answer, we shall use calculator. .81 and sum. That is 6.81 times 10 to the power of 8 years. That will be the one more dollar will be the GDP of so many years of the USA. If you want it million, we have to bring it to 10 to the power of 6. So it will come to 681 times 10 to the power of 6 years. Now think of it. One more dollar will be equivalent to 681 million years of GDP of the UC. Now imagine how huge that number, one mole is. To find the mass, we use a balance. Now I put these 4 pens on the balance and I measure the mass of it. It is 80 grams. So the 4 pens mass is 80 grams. Now if you take 1 mole hydrogen atoms and put on that, what will be its mass? 1 mole hydrogen atom I take and I put it here and I am going to read the mass of it. Then it will be 1.008 grams. Atomic mass of hydrogen 1.008. But the actual mass of 1 mole hydrogen atoms will be same number 1.008 and grams. If you take 1 more nitrogen atom and put on that balance, what will be its mass? Atomic mass of nitrogen is 14 U. If I put 1 more nitrogen atoms here, its mass will be 14 grams. How simple it is. So if I take nitrogen, not molecules, atoms, because nitrogen gas atoms, 1 mole atoms I put, and its mass will be 14 grams. Another example, let us see. We know water, H2O. Each molecule contains 1 oxygen atom and 2 hydrogen atoms. Hydrogen atom, let us take it roughly as 1. So the mass of 2 hydrogen atoms will be 2U. The mass of 1 oxygen atoms will be 16U. So together the molecular mass will be 16 plus 2, 18U. If I put 1 more water molecules on this, its mass will be 18 grams. Very easy to calculate. Now we know all the requirements to do this problem. We know the atomic mass of nitrogen 14U, atomic mass will be 14U. Hydrogen atomic mass will be 1.008 U. 1 mole if you take 1.008 gram. 1 atom if you take, it will be 1.008 U. If you take 1 atom of nitrogen, it will be 14 U. If you take 1 mole atoms of nitrogen, it will be 14 grams. So that we know. And we know mole concept. And we know 4-box method. Now we are ready to do this problem. Now let us see how easy this problem is. Ammonia gas. It is Na3. Atomic mass of nitrogen is 14U. Atomic mass of hydrogen is 1.008. For convenience sake, let us take it as 1U. If you want more accurate answer, then we shall use 1.008. So 3 hydrogen atoms, its mass will be 3U. So the molecular mass of ammonia gas will be 17U. If we take 1 more molecules of ammonia gas and put it on that, its mass will be 17 grams. Mass of 1 molecule of ammonia is 17U. Mass of 1 more molecules of ammonia will be 17 grams. In the 17U, 14U is nitrogen, 3U is hydrogen. Therefore, in the 17 grams, 14 grams will be nitrogen, 3 grams will be hydrogen. In other words, 3 grams of hydrogen will chemically combine with 14 grams of nitrogen and it will produce 17 grams of ammonia gas. Here nothing will be left out. No hydrogen will be left out, no nitrogen will be left out. Now I will explain 4-box method of doing problems. It is only 5th grade math put in a slightly different language. In a problem, math and calculation are involved. Now let us concentrate on the math part of the problem. Because of that, let us make calculation very easy. Now you can concentrate on the math part of it. Let us take the very simple problem. Cost of 10 meter of cloth is $40. Therefore, cost of 1 meter of cloth. All of us know the answer quickly. We can tell the answer quickly. But how do you arrive at that answer? We divide 40 by 10 and we get the answer is equal to $4. So the operation involved is division. To understand the math involved in the problem, let us use 4-box method. I am going to draw 4 boxes. Let us call this as box number 1. Box 1. This let us call it as box number 2. This box number 3. This box number 4. The problem is $10 cloth. Its cost is $40. We are going to find the cost of 1 meter. Question is how many dollars? This is the question. Let me use a language for this. For some number we know the value. For 1 we are going to find the value. So let us call this as some number to 1. Meaning in the problem for some number they have given the value and they have asked us to find the value of 1. We can get the answer using one of the operations. What are the operations? Addition, subtraction, multiplication, division. Which operation is involved in this? All of us know it is division. So what we do, this 40 goes to the numerator and this 10 goes to the denominator and we get the answer as $4. If you are going to find from some number to 1, box 2 number goes to the numerator, box 1 number goes to the denominator, then you get the value. This I call it as some number to 1. Now if the numbers are different, you don't worry. Whenever it is some number to 1 in directly proportional problems, box 2 number will go to numerator, box 1 number will go to denominator, whatever be the size of the numbers. The choosing the operation does not depend on the size of the numbers given in the problem. If it is directly proportional and some number to 1, definitely box 2 number will go to numerator, box 1 number will go to denominator. You will get the answer. If the numbers are big or small or not easy numbers, you will find difficult in the calculation part of the problem, not in the math part of the problem. Math part of the problem is over. 4 box contains 3 parts. In the first part we learn sum number to 1. That we have already learned. Now the second part is the reverse of it. For 1, the value is given. We have to find the value for 30. Unit value is given. I call this unit value is given. For some number you have to find the value. Let us call this as 1 to some number. The first one is some number to 1. The second part is 1 to some number. Now we have to choose the operation. This is directly proportional problem. So 1 to some number, among the 4 operations, we choose multiplication. So what do we do? We write this 4 here and we multiply this by this number. And we get the answer. In some number to 1, the operation was division. In 1 to some number, the operation is multiplication. This is the second part of it. First part we call it as sum number to 1. The second part we call it as 1 to some number. Now let us enter into the third part. Now let us learn the third part of the method. For some number the value is given. For some other number the value is asked. We call this as some number to some other number. What are we going to do? We will find for 1, for 10 meters 40, for 1 meter how much? We know it is division. Then for 1 meter so much, 30 meters how much? That is multiplication. So in between there is one method that will run through our mind. So I will write it small 1 here meter, meter, meter. So sum number to 1, the operation was division, we know that. Now this is the value of 1 meter. Don't do the operation, let it be as it is. If this is the cost of 1 meter, then to find the cost of 30 meters, you have to multiply this number by 30. So we do this 40 by 10. Understand, this is the cost of 1 meter, but we are not doing the operation. This is cost of 1 meter. Then cost of 30 meters we multiply by 30. Now we get the answer 120. This is the third part of it. But this middle part we are going to do in our mind itself. For understanding I have written now. Now in future we will not write it. We will do it in our mind. For 10 meters so much. Then for 1 meter 40 divided by 10. Then for 1 meter 40 divided by 10. Then for 30 meters 40 divided by 10 times 30. Now this method we call as some number to some other number. This is the third part of our method. In 4 parts method there are 3 parts. First part sum number to 1. Operation is division. Second part 1 number to some number. Operation is multiplication. Third part is a combination of these two. Some number to some other number. But what we do is we find some number to 1 in our mind and then we jump from 1 to some other number. The middle line will go through our mind. This is called some number to some other number. Now in problems, the numbers will not be so easy. It may be 1.008 into 10 to the power something like that it comes. But the operation will not change. The operation that we choose, division or multiplication, the operations we choose does not depend on the size of the number. Whatever be the size of the number, some number to 1 division, 1 to some number multiplication. Remember well, The operation does not depend on the size of the number. Now, this is a case of third part. Some number to some other number. Both are fractions. Don't worry about it. Some number to 1. This number should go to the numerator. This should go to the denominator always. Then that is the value of 1 kilogram. Then 1 to some number, we have to multiply by this. So first let us find for 1 in our mind. Some number to 1 we have to find. So this box 2 number will go to the numerator. Box 1 number will go to the denominator. Now this is the value of 1 kilogram. Now 1 to some other number, that is multiplication. This will go under multiplication. Now calculation. We know this by this we got 50, I think you remember that. So 50 times 0.5. That will give you $25. This is half. 50 times half, 25. Whatever be the size of the number, don't worry, the operation will be the same. Some number to 1 division, 1 to some number multiplication. This is true for directly proportional problems. What we have understood now is 3 grams of hydrogen will combine with 14 grams of nitrogen to yield 17 grams of ammonia. Three grams of hydrogen will combine with 14 grams of nitrogen to give 17 grams of ammonia. Therefore, 3 kilograms of hydrogen will combine with 14 kilograms of nitrogen and it will yield 17 kilograms of ammonia gas. Now in this problem, hydrogen is 10 kilogram, nitrogen is 50 kilogram. We do not know anything is excess or not. Now we are going to find that. We will use 4-box method now. I am not going to write this here. I will write only boxes. Box 1, box 2, box 3, box 4. Three kilograms of hydrogen will combine with 14 kilograms of nitrogen. Now the question is, there are only 10 kilograms. So 10 kilograms of hydrogen will combine with how many kilograms of nitrogen? This is the question. Whether 50 grams will be more or less, we are going to find out. We have got 50 kilograms of nitrogen. But actually 10 kilograms of hydrogen requires how many kilograms of nitrogen? Box 2 will go to the numerator. Box 3 will go to the denominator. That will give 3 kilograms requires 14. Then 1 kilogram, it requires this many kilograms of nitrogen. For 1 kilogram of hydrogen we have found out. Then this is for 1 kilogram of hydrogen gas. Then for 10 kilogram of hydrogen gas, we multiply by 10. So many kilograms of nitrogen required. So 10 kilogram hydrogen requires so many kilograms of nitrogen to produce ammonia. How much is this? This will be 46.67, it goes 666, it will go 46.67 kilograms of nitrogen required. 10 kilogram of hydrogen will combine with 46.67 kilograms of nitrogen. But for 10 kilograms of hydrogen, we have got 50 kilograms. So 50 kilograms, it is in excess. How much excess? 50, 46.67. So 3.33 kilograms of nitrogen is in the excess. It will not react. It has no hydrogen to react. Now the second question. Identify the limiting reagent. Which is limiting the production? Which stops production? Which is less will be the limiting reagent. Now here nitrogen is excess. Hydrogen is less. Hydrogen is completely exhausted. Nitrogen is left out. So the limiting reagent is hydrogen. First question, calculate the ammonia gas formed. (10 kilograms combined with so many kilograms of nitrogen. So total mass of it will be 46.6 kilogram of nitrogen plus 10 kilogram of hydrogen. So you will have 56.67 kilograms of ammonia you will get. Now we have answered both the question. The amount of writing or the amount of calculation is much less. What we did, I will go through again. 3 kilograms of hydrogen combines with 14 kilograms of nitrogen. Then 10 kilograms given here. 10 kilograms of hydrogen will combine with how many kilograms of nitrogen? We used 4-box method, 14 divided by 3 into 10, and we got 46.67 kilograms of nitrogen. So simple. 10 kilograms of hydrogen will combine with 46.67 kilograms of nitrogen. So the total mass of ammonia will be this kilogram plus this kilogram. Nitrogen mass plus hydrogen mass. Ammonia mass will be 56.67 kilograms of ammonia gas. Second question also we have answered. Hydrogen is less, nitrogen is in excess. So hydrogen is a limiting reagent in this reaction. In this problem, to make our calculations part easier, we took the atomic mass of hydrogen as 1U. If you want more accurate answer, you have to take the atomic mass of hydrogen as 1.008 U. Now, if it is 1 U and 3 hydrogen atoms would give 3 U. But if you want more accurate answer, you cannot take it as 1 U, you have to take it as 1.008 U. Then for 3 hydrogen atoms, you have to multiply by 3. You will get 1.024 U. Now 3 went to the denominator. Now this 3.024 U. In our problem, 14 went to the numerator, 3 went to the denominator, and then we multiplied by 10. Now in this case, if you want more accurate answer, 14 will go to the numerator, this 3.024 will go to the denominator, and you have to multiply by 10. See this. The problem has not become tougher. only the calculation part has become tougher. So in all the problems there are two parts, math part, calculation part. Many students struggle only in the calculation part, not in math part. Math part is too simple. If you assume it to be a whole number, math was very easy. So you should get rid of the fear of number. First you must get rid of the fear of the number. Then all the problems will be very easy. They won't give 3, 5, 10 like that. They won't give easy numbers. All numbers will be this, like this. Or you will have 10 to the power of minus 21, 10 to the power of minus 23, 10 to the power of plus 23. You will have all those things. So first become strong in calculations. If you understand the 4-box method, most of the problems in physics and chemistry will become very, very easy. Here I want to warn you. There are two types of relationships. You should not confuse them. Now I will explain that. What are the two types of relationship? There are 10 meters of cloth, cost we said $40. If another one buys double that length, say 20 meters, then what will happen to the cost? That will also be doubled. It will become $80. If another person buys half of it, 5 meters of cloth, this is half. So this cost will also be half. It will cost $20. Let me call this as quantity 1. Call this as quantity 2. Now, if quantity 1 this side, quantity 2 this side. If quantity 1 is doubled, the quantity 2 is also doubled. If quantity 1 is halved, quantity 2 is also halved. Never say quantity 1 increases, quantity 2 increases. Don't use that language. You must use double, triple like that. If quantity 1 is doubled, quantity 2 is also doubled. If quantity 1 is halved, quantity 2 is also halved. Let me take another example. Now I make it 5 times. Now quantity 1 becomes 5 times. Then quantity 2 will also become 5 times. If quantity 1 becomes 5 times, quantity 2 will also become 5 times. Suppose I buy 2 meters of cloth. That is, it becomes 1/5. Then this will also become 1/5. See how quantity 1 and quantity 2 behave. When quantity 1 becomes 5 times, quantity 2 becomes 5 times. When quantity 2 becomes 1/5, quantity 2 will also become 1/5. This type of relationship between Q1 and Q2 is called directly proportional. In all the directly proportional problems, you can use the 4-box that I have taught you now. Roughly 80% of the problems will come under directly proportional. There are other 20% of problems, they will come under inversely proportional. What is inversely proportional? It is just the opposite of it. Let us take an example. We are going to build a big compound wall around a campus. And I call a contractor. And I ask him, how many days will it take to finish this work? He thought for a while and told me, if I employ 20 workers, I will be able to finish it in 60 days. 20 workers, I will be able to finish in 60 days. Workers. I told him, no, I want to finish it sooner. Then he told me, yes, I'll try to finish it in 30 days. So he was going to employ 40 workers so that he can finish it in 30 days. See this. 20 workers can finish in 60 days. If you double the number of workers, the number of days will be halved. When the number of workers is doubled, number of days is halved. Now you tell me the answer. Suppose if he has got only 10 workers, that is halved. In how many days will he be able to finish that job? 20 workers can finish it in 60 days, then 10 workers will take more time. So 10 workers will be able to finish it in 120 days. This type of relationship between workers and number of days, when the amount of work is constant, is called inversely proportional relationship. When quantity 1 is doubled, quantity 1 is doubled, quantity 2 is halved. When quantity 1 is halved, quantity 2 is doubled. They operate in the opposite way. In the directly proportional, when quantity 1 is doubled, quantity 2 is doubled. In the inversely proportional, when quantity 1 is doubled, quantity 2 is halved. When quantity 1 is halved, quantity 2 is doubled. So this type of relationship is called inversely proportional. So there are two types of relationship in most of the physics problems. Either it will be directly proportional or it will be inversely proportional. For directly proportional, we learned it. Some number to 1, 1 to some number to some other number. In the case of inversely proportional also, we have to learn some number to 1, 1 to some number to some other number. Now let us learn that one. "20 workers can finish the job in 60 days. Then one worker will take how many days? 20 workers in 60 days. One worker will take 60 times 20 days. This sum number to 1. In the directly proportional problem, sum number to 1 division. In inversely proportional problem, sum number to 1 is multiplication. Now go to the next picture. If one worker can finish the job in 120 days, the 1200 days, then 40 workers will finish in how many days? One worker can finish in 1200 days. 40 workers will finish it in 30 days. Understand the difference? In directly proportional problem, sum number to 1 is division. In inversely problem, it is multiplication. In directly proportional problem, 1 to some number is multiplication. In inversely proportional problem, 1 to some number is division. Here box 1, box 2, box 3, box 4. Box 1, box 2, box 3, box 4. Box 2, sum number 1, box 2 times box 1. Here if you take this as a box 1, box 2, box 3, then this is 1 to some number. In 1 to some number, it is division. Now if you understand the directly proportional and inversely proportional, and if you use this 4-box method, most of the problems will be very easy. Math part will be easy, but calculations part may become tougher. That you have to manage somehow. improve your calculation skill. That's the only way to do problems. In inversely problem also, there are three parts. Some number to one to some number to some other number. Let us take the example. "20 workers can finish the job in 60 days. The workers' days. Then one worker will be able to finish the same job in how many days? That is the question. Some number to 1. What do you think? It will be less than 60 or more than 60? How many times more than 60 or what part of 60 will it be? 20 workers can finish in 60 days. Then this one worker has to do each of these 20 workers' work. So he will take 60 times 20 days. So in inversely proportional problem, some number to 1, you will have multiplication. So you will get 1200 days. Now let us go to 1 to some number. One worker can finish the job in 1200 days. Then 40 workers will finish his job in how many days? That is, workers have become 40 times. So the days will become 1/40th of it, 40 times less. So it will be 1200 by 40 days. That will be equal to 30 days. "20 workers, 60 days. One worker, 60 times 20. Multiplication. Be careful. In directly proportional, some number to 1 is division. In inversely proportional, some number to 1 is multiplication. In directly proportional, one number to some number is multiplication. In inversely proportional, 1 to some means division. Now let us combine them. This is some number to 1, this is 1 to some number. So we shall see some number to some other number. "20 workers, 60 days. 40 workers, how many days?" This is the question. Some number to some other number. This for one worker. Let us find it in our mind. We are not going to write it on the paper. It will go through our mind, but not on the paper. 20 workers can finish in 60 days. One worker will take 60 times 20. Then one worker will take these many days. Then 40 worker, the number of days will become much less. So it will become 60 times 20 by 40. You will get 30 days. Some number to some other number. Now let us see the box. This is box 1. This is box 2. This is box 3. This is box 4. Box 2 times box 1 divided by box 3. Remember that. In that it is just the opposite of it. Let us take this one. 20 meters of cloth, $60. 40 meters of cloth. How many dollars? 20 meters, so much. So 1 meter will be 60 divided by 20. Some number 1, 60 divided by box 2 by box 1. 1 meter so much, so 40 meter will be 60 by 20 times 40. Be careful. In directly proportional, box 2 by box 1 times box 3. In inversely proportional, box 2 times box 1. Here box 1 comes to the, directly from box 1 comes to the denominator. In inverse order, box 1 goes to the numerator. In directly proportional, box 3 goes to the numerator. In inversely proportional, box 3 goes to the denominator. Some number to 1 in directly proportional, some number to 1 we divide, some number to 1 we multiply in inversely proportional. 1 to some number in directly proportional we multiply, 1 to some number in inversely proportional we divide. Operations are interchanged. If you understand these two well, directly proportional and inversely proportional, 80% of the problems will become very, very easy for you. You need not memorize so many formulas. You can apply this 4-box method in electricity, in magnetism, in sound, in so many places you can apply this 4-box method. So, I am finishing this. Thank you very much. Have a nice day.